Good afternoon. I hope you are still awake after a lunch. So we are going to speak something interesting, something a little bit different from the security aspect. I hope it will be interesting, and let's make it more fun and interactive. Bit about myself. I'm working as a solution architect at Platform Line Systems, and my role here is like I work with customers mostly on the enterprise segments, and I do basically like help in designing, planning, and implementing Kubernetes solutions, Kubernetes and cloud native solution on the enterprise level as well as for the DevOps adoption. I have been CD Foundations. So if many of you don't know CD, so CD is for continuous delivery. It's like, again, one part of the Linux Foundation program. And I'm also a Calico Big Cat ambassador. I have been a speaker on multiple conferences like KubeCon, DockerCon. And like mostly when I'm not working, I'll be, like you will find me in most of the meetups, and I'm also a tech blogger. Like I write different blogs on social handles. You can find me there. On to Neel.
Yeah, hi everyone. So I am Neel Shah, a DevOps community guy. I work as a developer advocate at Middleware. It's a full-stack cloud observability platform. And apart from that, I used to host meetups, conferences in my local region, that is Gujarat, and have maintained more than 50 plus hackathons and have given talks in 10 plus conferences, including the KCDs, PlatformCon, and different conferences. So yeah, here the main question arises. Why we need container checkpoint and restore? Can anyone answer this? No? Let me go ahead then.
Before that, quick show of hands, how many of you are working in the security space in the cloud?
Maybe in DevSecOps or somewhere?
Yeah, DevSecOps. Wow, that's a good number. Yeah, so, I mean, the talk is all for you. Just kidding. The talk is for everyone.
So yeah, many at a time software breaks. We don't know why it actually break. We don't know the actual error. So it is better to have a checkpoint of that. Next is, when we do a live container migration, there are a lot of problems that occurred with that. We don't know why actually it's happening out. So we need to restore that point, and we need to go and have a backup of that also. Next is, some of the processes, some of the containers need a lot of restart time. We need to warm up them. So it is better to have a checkpoint, and then we can go at them. Need for reproducible state. Why we need this? Because sometimes some attackers have adapted it to you. We need to set up the same environment so we can have better understanding, and we can have whole case study of that. So it will be helpful for us. Next is forensics. So if an attacker has attacked, then all the footprints we need, because the whole DevSecOps team will need a whole case study of that. So for security purpose, we need to do a whole forensic check of that, and checkpoint will help you out that. So need for resilience, why we need for resilience is, and many a time what we do is, if the container breaks, we just restart that. So with that, we have loss of things, loss of runtimes, and we lost memory contains, file descriptor, hierarchy of files, and everything. Because the process has abruptly stopped in between there. We don't know how actually where eventually the process has stopped out. Why does this matter? For a stateless app, it doesn't matter, because there are different microservices and they are not dependent on that. But consider a scenario where it's a complex microservice, like ML pipelines. If you see if some process break, then it will incur a lot of loss for company and eventually a lot of loss for the developers also. Because there are a lot of things kept going on parallelly, they are dependent on each other, and eventually if something breaks in between, it will be a chaotic situation out there. In security incidents, we lost a lot of valuable evidences, so it is better to have a precaution of that and have a checkpoint enabled there. In debugging time, you lose like almost, you need a RCA there, so it will help you out to do RCA properly, and we'll have more of the forensic investigation for that. The problem with traditional monitoring, what it was is, post-mortem investigation is very troubleshooting. So consider a scenario if a container crashes, then logs vanishes, and you don't have the footprints of that with you. Apart from that, traces. So eventually a process has stopped in between. If you don't have traces of that, you won't be able to see actually at what position, at what time the process has stopped of that. So you need all the things before your hand whenever the container crashes out there. Runtime anomalies like memory corruption, runtime container corruption, the whole thing won't be with you if you consider traditional recovery system. Security forensics is blind. Why I'm telling that? Because you will see in a breach or compromise scenario, we are losing a lot of evidences, we are losing a lot of things which we don't know. Eventually, an attacker has attacked and you don't have any footprints, then you won't be able to see what he was actually trying to do that. So you don't have an opportunity to understand the memory malware and everything. So for that, we will come up with a solution. So consider a scenario, a hacker is doing something on your container and you are hacking a hacker. You are hacking a hacker and hacker is not knowing what actually you are doing. So you will have all the footprints of the hacker with you and you will eventually see what actually hacker is doing out. It's just for fun, but yeah, we'll go ahead, Suman.
Yeah, so as Neel mentioned, we saw all the traditional problems with like debugging a container that has been compromised, right? So how to do a little bit reverse engineering and try to see from a hacker's perspective what we can do. So that is what CRI-O as a tool will help us. So let's see. So CRI-O is a checkpoint restore in Userspace. So this is a Linux tool. So initially it was started by Virtuo in November 2013 as a proof of concept. Hello. So yeah, so it started in November 2013 as a proof of concept, and apart from doing a container checkpointing, it does have multiple use cases like doing a live migrations, doing a snapshot, producing a reproducible state across multiple clusters. So how does CRI-U actually works? So I think for you, there might be a confusion between CRI-U and CRI-O. So just to differentiate, CRI-O is, CRI-O is a container runtime interface, which is one of the prerequisites will come onto this later point of time. So CRI-U is again a Linux tool. It's basically what it does, three things. Pause a currently running processes, save its completed state onto a disk, and then restore it later at any point of time on a different host wherever you need. So this is the simplest way we can explain. So what's happening? So there's a process that is, let's say a container that is running. So CRI-U goes inside it. It injects a parasitic code. That particular code at certain point of time, it basically initiates a ptrace dump and it collects all the processes together with the open file descriptors, file sockets, memory pages, everything, and saves the state onto the particular disk. So this is the way how we basically restore everything which is currently running on a particular container. And once you have that particular state available, then you can basically take it into a sandbox environment, do further debugging on that, and you can restore that particular file that you have taken back into a running pod with the same state where it was actually running. So CRI-O can actually has multiple capabilities. It can actually take a snapshot or a checkpoint of the complete process trees within your container that is running. That means all the parent process, child processes of a particular application that has been deployed, the complete memory, whether it's a heap dump, pages, cache, registers, everything, the open file descriptors, the network state, that includes your networking configurations, TCP socket, all the namespaces and C groups that are defined. Why this is powerful? Because we don't have to do any guesswork. Whatever you are doing, you are basically taking the actual running state of that container and you are doing debugging on that. And it's ideal for live migration, forensic analysis, and faster than restart recovery, like for application which takes longer time to restart. So coming into the Kubernetes side, so CRI-O has been a much more, I would say, a formidable tool for Linux side of the things. With Kubernetes, there is a little bit difficulty here because if we think about on a very holistic level, so you think that there is a node that is built for a Kubernetes. Inside that, you have kubelet running, and then you have a high-level runtime called as a CRI-O, and then you have a low-level runtime, which is basically run C or any other processes, right? So when you are, so it is very difficult actually to directly talk to the runtime of the kernel directly by invoking a kubectl command, right? So CRI-U as a whole doesn't talk with the kubectl. We have to invoke them via the kubelet API. So coming into how it came into Kubernetes is through this KEP, which is 2008, which was an enhancement description that is still open. And if we see the timeline, CRI-O came into the Kubernetes with 1.25 Kubernetes version, which was in alpha. With 1.30, it graduated into the beta release. Now with 1.30, it is stable. But the proposal is still on that how we can integrate CRI-O to work with kubectl as a CLI, because that would help many of the engineers who are not familiar much with the API side to actually use this tool to do further debugging. So if we look into the overall workflow, how container checkpointing works, the process is fairly simple. As I told, like what it does, the CRI-O basically clones the complete processes of that particular container. Basically, it invokes the ptrace command, which basically does the tracing of all the open processes, files, memory pages, heap dumps, everything. Restores it into a disk. It can be your own local node, or it can be any other state. You basically take that particular dump tar file outside your environment into a sandbox where you do further debugging to understand if that particular container has been compromised or not. If it is not compromised, if you want to restore that back to its original state, you have to basically apply the security runtimes. So there is a tar file that is there, and you just need to add it back into a scratch container so that it can actually work back as a normal, like you can basically create that as a normal pod back into the cluster. And then you resume execution where you get to run from the point where you have left actually. So let's see how checkpoint can be triggered.
So yeah, as Suman told how the process is going on. So let's see how the checkpoint is triggered. So the first thing will call the kubelet API. The kubelet API will call the checkpoint. And you can see the path over there. And the checkpoint will create a tar file on this path. So the tar file includes a lot of things. Suman will tell in the next slides. But before that, if you want to improvise checkpoint, so what are the prerequisites? So let's see that. So for the prerequisites are, you need to have a cluster having version 1.25 plus. And you need to enable some of the feature flags in your manifest file so it can be applied, and the checkpoint can be directly applied over there. And one thing is, it's on only container runtime CRI-O. It is available there only. So you can use that. Yeah, going ahead.
Yeah, so the actual information is contained into this tar file that is actually checkpointed. If we actually unzip that, we'll get a lot of files. So what happens is, like when checkpointing is actually done, there is a conversion of all these processes into certain images using protobuf. And these are the informations which gets dumped into that particular archive. So it contains bind.mouse, which contains details about all the mount points in the container. It contains config.dump, spec.dump, which are the metadata information that is actually needed to be restored back into the pod when we want to do a restoration. Then it has the checkpoint folder, which actually contains all your processes, the memory pages, the CPU, CPU registers, everything created as an image file, which you cannot do, but there are tools that can actually help us to debug that. And then there are dump.log file, which contains the complete debug output of the CRI-O during checkpointing. And rootfs.diff.dar, it contains the different change files that happen within the container image, the point when you checkpoint it. And stats.dump basically contains the statistics of that particular dump. So having like said a little more on this checkpoint, let's go a little bit on the real-time demo. So just yeah, I think this is visible. So I have a cluster. Just show you. It's like yeah. So this is just a normal, K3s clusters that is running on 1.33.1 version. And so what you need to do, as Neel mentioned, we need to specifically enable some of these settings in the configuration cluster. Like for example, in this case, when we are implementing kubelet, we have to implement this feature get container checkpoint to true, enable feature get for API server, for controller manager, for scheduler, everything, right? And the important fact here is that you need to enable the CRI-O inside the CRI-O configurations. So here is like we enable the enable CRI support set to true, which basically enables checkpointing that particular container or the container which is running inside that pod. And you have to basically set drop in for CTR set to false, because this will allow the checkpointing tool to restore it further back into a pod that might be running on a different cluster. So let's see. So yep, I have a simple YAML to deploy. So I'll just deploy that. Sorry, I think wrong namespace. Yeah, so this is simple pod, which is kind of a counter where it is running inside this namespace. And once we do a curl to this IP, so it will just increment that counter, like based on how many responses that we are giving. So like we can basically run some, like create some file also here, just dump some data. Maybe we can create some secret here as well. Okay, so now this pod is running. Now let's say I assume that I suspect this pod has been compromised. So how CRI-O can help me in this process? So what we do immediately is basically we invoke the kubelet endpoint, which is running on 102050, and on this particular checkpoint with this particular namespace under this particular pod and container by passing the key and the cert and the CSRT informations. And then I just run this, and it basically creates a point-in-time snapshot of that particular container at this point of time. So let's see. So if I just run val leaf. So here you can see it created a point-in-time snapshot with a timestamp actually. Now we have a tool called as checkpoint CTL, which basically helps us to do all the job. So this is the current version, which is the latest one that is running. And if we just run checkpoint CTL list, it should show me what is the current, what is the checkpoint that is there inside my system, right? So basically, it identified that there's a pod, demo counter, container, and an engine that it detected is CRI-O. Now, we can get more information around this checkpoint as well. For that, what I will do, I will just copy this complete checkpoint into some simple name, because this is a very huge name. So let me do that. And something like demo counter dot. And then I can use checkpoint CTL show demo counter dot. And you can see it gives more high-level information about the IP that it has checkpointed, the checkpointing size, what is the size of that particular file, and root FS. Now, we need to get more deeper into this particular file. So we have a command called as an inspect, which basically helps us to give more low-level information. So let's see this. Yep. So this is the complete information about this particular container or the pod which we have checkpointed. So what it will give you the dump statistic, like how much time it take to freeze that particular container inside that pod, what is the overall time, the memory dump time, memory write time, the complete metadata information. And this information would be needed back when we'll be actually restoring this container back into another pod in a different cluster. And the interesting part here is we can get more level information on the process tree. As you see that there are 1, 2, 3 processes are running. Now you can actually, if you think that when a particular container gets compromised, you would see a different process may have triggered inside that. There might be a different ports that has been opened, or there are some unknown files which should not be there, right? So all these things you can directly see here. And this, mind it, you are doing it transparently without anyone knowing that you have done something on that particular container. Like you haven't installed any tool, or you haven't started doing any analysis directly on that container. So here you can actually understand if there is someone who is kind of snooping into that particular container by checking if there's some unknown ports that is running which should not have been run. And these are the open files. And these are the mount points. So you get a complete postmortem of you get to do a postmortem of the complete pod that you have deployed. Now, coming to that, another interesting is that you can actually get into the memory of that particular pod. So I think this is demo. So I'm just doing a memory mem parse of that particular first process ID, and I'm just giving head because it's a long information. Will not be able to display it on the screen. So you can actually display the memory pages content. So sometimes what happens, there are some malware which actually changes this particular information or the ASCIIs within that particular container, right? And these are very difficult to detect using some standard tools. And Checkpoint here comes to the rescue where it helps to identify what are the different memory pages that has been changed over the life cycle. Now, let's say you think that, okay, these are good, right? Now, we can actually go a little bit deeper to understand that. For that, CRI-O has one more tool called as CRIT. So CRIT basically is a tool built with Golang, and that actually helps to do further deep down into that particular process. So let's see. For that, I will just unzip this tar file and into something. Maybe I'll just put it inside a Checkpoint folder. And then I'll just go inside the Checkpoint folder. And these are the all informations which I was actually showing you. Now, CRIT can actually help you to basically analyze further on that. So let's see. So let's say I just do a CRIT show, and all these are dumped as images, as I was mentioning. So if I just do a CRIT show, it will show me which particular process was running in that particular image. Similarly, since I have 3 processes, there are 3 files which has been created here as an image process. So it's just running a counter.py. It's just a Python application, and just these 3 processes running. Now, for example, I have created some passwords, right? Now, I want to see if that password has been compromised or not. So for that, I can actually use the same folder to analyze whether there has been any change in that particular password or not. And so this is the password which I initially set while executing that particular container. And you can see that this is contained in this particular page, pages.2.image. So this is the minute level information that we can get from a container that is running a pod and maybe have been compromised. Now, let's say you think that, okay, I have done every testing on my sandbox environment and I feel that, okay, it is fine, there's no changes. I need to restore it back to the cluster, right? Now, what you want to restore from the same state from where it was checkpointed. So for that, what we do is like we add this particular tar file into a Scratch container. We add some configurations. So I'll just show that. One moment. So here is like I'm adding this particular container into, like I will use a builder tool basically to build it. And I mean, you can use any other tool as well. There's no specific limitation. I just use builder, and you can add it to a container. You can do all the configurations that is necessary, and then you commit those changes back into the image, right? And push the image back into the registry where you can use that. So I have already done that, and I'll just create that pod back with this pushed or the change image. Yep. So let's see. So this restore container is the one which has been created back from this checkpoint file, which has been analyzed. Now let's try to do some testing, whether I have been able to restore it from the same state from where I have captured that. Yep. So you see the counter starts increasing from 7, 8. Like last increment was 6 from the point from where it was checkpointed. So this is kind of a seamless, transparent. No one knows that you have done something inside the container, what you have actually, or have actually done some kind of a debugging analysis, or even made some changes that is needed, right? So that is the power of CRI-U, which basically help us to transparently do a forensic analysis of something which is currently going on the environment.
So yeah, we are seeing the demo. Now let's consider a real world scenario where we will use this. So consider a scenario where a container is compromised. So what you will do is, imagine your security system has been down, and you detect a suspicious behavior over there in a running container. So what we generally do is, we kill the system, we kill the pod, we again the same thing. Is that the true thing? No. Instead of that, what we need to do is, instead of use a snapshot of CRI-O and enable the checkpointing in your manifest and use the manifest tar file, so you have better understanding of all the forensics, all the footprints of that, and you can be able to understand like why it happened, and you can understand the errors, why it was occurred, or if it was a hacker's attack or something that way. Because this preserves the in memory, and you have all the payloads and all the file detectors, each file hierarchy, you also have traces sort of thing. So you have an understanding of all the files that will happen and all the processes that were going on in the previous container that was running properly. Apart from that, it will be benefited for the security teams, because most of the companies have their DevSecOps team. So it will be beneficial for their security team to do a whole case study of that, whole case study of that process, and it will be helpful for them. It will also help you correlate on different portion, correlating with that in logs and times, and also memory consumption. So it will be helpful for them. It will also sometimes also investigate how the malware happened, because the attackers had some footprints of their malware. So it will be helpful for you to understand what malware it was, and it will be helpful for your security team to understand better. These are some of the references. If you want to see, you can see that. And this is a resource. Suman showed the demo. Here is a GitHub of that. We have mentioned all the things step by step over there. So you can also create the same thing, and you can try it out. Believe us, it is a good thing. Like, at least try it out if you're in DevOps or DevSecOps. It will be helpful for you. Yeah. 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 Thank you for it. If anyone has any question, feel free to ask.
No. There is no direct requirement of any CSI here. I mean, because CRI-U under the hood only talks with your container runtime interface, like the high-level runtime and the low-level runtime, which is runc or any other like processes that is running, right? So. No, those are not snapshotted. What is snapshotted is what it is there inside that particular pod or the definition. Like, for example, you have mounted some PVC points, right? So this will be snapshotted. But it is not snapshotting the data. It is snapshotting the configurations only. Huh. Right. So it is in memory. So for stateful, what you need to do, we actually need to restore the complete pod together. Sorry, I mean the complete cluster together, because in that same cluster, let's say there are pods, there are volumes that are mounted, right? So complete things you have to restore that. You cannot. No, no, no. So this is a stateless app that I just showed you. Yeah. No, it works. That's what I'm telling. Like, so for stateful app, you need to first like, so yeah. So for that, actually, you need to use some other backup and restore tool that can actually do that. So you, yeah. Yes, yes, yes. Hmm. No, no, pause means the CRI-O within that particular container, it pauses that process. It is not pausing the pod actually. It's pausing the state of that. Yeah, right. It was still running. Yes, yes, yes. It will move, but then it will not be reflected here because the point in time from where you have done that information it will have. Because the idea here is that the hacker should not know that I'm doing something there. If you are just stopping or something, then means there's a flag. Yeah. No, no problem. So yeah. No, actually, the one of the few features that this particular tool has, like for which it was developed, was a live container migration. So you can actually take the complete container state defined on one cluster, create another cluster, and do a kind of a checkpointing there. No, no, not RC. I mean, he's just talking about outside the security. So it's just like a doing a migration of the containers. Yeah, container migration. And secondly, another useful thing is like for certain applications, right, which take some time to come up. Let's say some Java applications, right, which take some of the time to come up from a warmer state, right? So you can do a checkpointing of those particular states so that once it warms up and immediately once you restore that, it will start from immediately. So that warming time will be mitigated. I have something in my GitHub repo. I can share that probably. I didn't use that here. Yeah. Yeah, yeah. I'll share that. I have actually.